right, so this week we've been balancing chemical equations, and you've had lots of practice so far on the computer activities, and hopefully you were able to kind of get some immediate feedback there to see how you're doing with balancing, and then also with the coloring activity to see if an equation is balanced or not. And today we're going to be balancing specifically combustion reactions and kind of take a moment to focus on them because they can be a little bit tricky sometimes. So when we're balancing a combustion reaction, the process we want to take is first to balance carbon and hydrogen, and then lastly balance out the oxygen. And the reason we do this is because the oxygen on the left side is only in one spot, but on the right side it's split. And on our reactant side, it's going to have to be an even number, and sometimes it's an odd number when we're on the right side. As you can see here, if I add these up, 2 here and 1 here is 3. So if I wanted to balance this out and make it 3, I would need a 1.5. But all of our coefficients have to be whole numbers. So what we'll do instead of having a half number is we'll do this third step, double all the coefficients if necessary. So let's do this first example, and hopefully it will start to kind of wash out and make a little bit more sense, finding those that need to be doubled. So first things first, we'll make our little table here, carbon, hydrogen, and oxygen. And when I'm writing these, I'll just draw a line at the arrow and list my elements. So carbon, here I have 4, hydrogen 10, oxygen 2. And the products, I have 1 carbon, 2 hydrogens, 3 oxygens. Okay, so let's start balance carbon and hydrogen first. So I'm going to start with the carbon, placing a 4 here. That's going to make my carbon 4, but it's also going to make my oxygen 8. 4 times 2 is 8 plus 1, so that'll make it 9. And then hydrogen on the left side I have 10, so I'm going to put a 5 here, multiplying my H2 to get it to be 10. And now my oxygen count is 8 plus 5, 13. Now to balance out my oxygen on the reactant side, I'm going to need half of that, right, because we have this 2 here, which if we were allowed to use decimals would be 6.5. So I'm just going to write that for tracking it in our minds, but we can't put 6.5 in the blank. It has to be a whole number coefficient. So that leads us now to doubling all of the coefficients. Currently we have 1, because that's blank, 6.5, 4, and 5. But we can't have a decimal, so what we're going to do is just double everything. And because this is, the goal is just to have it balanced or be the same number, it should also just keep the numbers the same, simply doubled. So let's go ahead and double all of our coefficients I wrote up at the top. So that would make this a 2, 13, 8, and 10. Now let's check and make sure our counts all match. They should, because they matched before. It should just be twice as much. So now we have 8, 20, and instead of 13, we have 26. And on this side we have 8, 20, and then we have 16 plus 10, 26. So it is balanced, and all of our numbers are whole numbers. Yay! So our final answer would be 2, 13, 8, and 10 as the coefficients. Sometimes you need a double, sometimes you do not. So let's do number 3. I'll let you do number 2. We can see another example here. Count your atoms. And then start balancing carbon and hydrogen first. So that makes 3, 4, And then my oxygens, looks like 6 and 4 is 10. So this time we have an even number of oxygens. So this will end up working out nicely. 5 times 2 is 10, and we're all balanced out. 1, 5, 3, 4, no need to double. So like I said, sometimes you'll need to double, sometimes you do not need to double, just depending on if our oxygens can make a whole number or if it's going to end up being a fraction. So go through and complete each of these combustion reactions for today's work. And while we're here, let's just go into some of these examples from yesterday and just make sure we're on the right page. So I'm going to go to page 7. This is after doing the balancing FET simulation. So I'm just going to do a couple of these with you. We have potassium, chlorine, and oxygen. I would suggest pausing the video and trying this on your own and then seeing if you are correct. So we've got 1 potassium, 1 chlorine, and 3 oxygens. On this side we have 1, 1, and 2. It looks like we're going to need to use a multiple that's in common between 3 and 2 so that we can get these oxygens balanced, which would be 6. So we're going to multiply our numbers to get them all to be 6 for oxygen. On the reactant side, we'll want to multiply by 2. And that also affects our K and our Cl because it multiplies through distribution. And then to get this oxygen to be 6, we'll put a 3 here. And lastly, to get our K and Cl balanced, we'll need a 2 here. And now we are all balanced out. Woohoo! 2, 2, 3. For number 2 here, we got H, Cl, Na, and O. Although OH is a polyatomic ion, notice that it is only on the reactant side. That's why I split it. So let's go ahead and just count, noticing that we have H's here and here. So that would be 1 plus 1 is 2, chlorine is 1, sodium 1, oxygen 1. And then on the product side, hydrogen 2, chlorine 1, sodium 1, oxygen 1. This one is already balanced. So you can either leave them all blank or put 1s in. Any blank is implied that there is a 1 there. I'll let you continue working on those on your own, and we'll do a couple here on page 9 as well. So let's do B. List them out: barium, chlorine, sodium, and sulfate. I'm doing this polyatomic ion as a unit because it is on both sides. So now we count them. 1, 2, 2, 1. 1, 1, 1, 1. All right. So this one looks like it's only going to need 1 coefficient to get our equation balanced. To get our, let's pick Na to do first, and look at that. It's actually going to take care of both because it will multiply by distribution to both the Na and the Cl. And we're balanced. 1, 1, 2, 1. Let's do one more. Let's do PaI5. So we got 1 and 5, 1 and 2. To make 5 and 2 balanced out, we're going to need a common multiple, which in this case is going to be 10. So we're going to try to get them both to be 10. You do that on the reactants by placing a 2 as the coefficient. That affects both of them. And then on the product side, I'm going to place 5. And because of the 2 on my reactant side, I will now need to place a 2 here as well. 2, 2, 5. Hooray, hurrah. Balanced. Okay, so you finish up, if you haven't already, all of the equations from yesterday and then work through these combustion reactions for today.